Welcome back. So we've talked increasing, decreasing intervals, we've talked concavity, we've talked points of inflections, relative maxes and relative mins. Now we're going to throw it all together and be able to sketch an accurate sketch without the use of a calculator of our polynomial functions. So the things that we're going to be able to find, and we're going to come up with all these things that we've talked about for the last couple of weeks. We're going to find our increasing and decreasing intervals. We're going to find our critical points. We're going to find our relative maxes and mins. We're going to find our points of inflection. We're going to find our concavity. If we can find our x-intercepts, we're going to find those. If we can find our y-intercepts, we're going to find those. And we're also talk about the end behavior of our polynomials. So without further ado, let's go ahead and look at an example or two to kind of talk about what's happening with these problems. So the first one, I think we've talked about x to the fifth minus 5 here recently. Can we sketch the graph of this? And what I want is a nice accurate graph and finding all the information that we can find. Well, the first thing I would do is go ahead and find our first derivative. First derivative is going to tell us our increasing and decreasing intervals. So if we look at our first derivative, we have 5x to the fourth minus 5. I'm going to set that equal to 0 to find our critical points. And factor out of 5, we get x to the fourth minus 1 equal to 0. I can go ahead and factor that if you want. We get x squared minus 1, x squared plus 1 equal to 0. And that's going to factor again to x minus 1, x plus 1, x squared plus 1 equal to 0. Remember, x squared plus 1 does not factor. We can't factor the sum of perfect squares. So we get the critical values of x equals 1 and negative 1. X squared plus 1 gives us a complex number. Lucky for you, we only work in the real numbers for calculus here, so we're not going to have to worry about that complex number. So we're looking at 1 and negative 1 for our critical values. What if I can cram this in here? Possibly. So we get negative infinity to negative 1 to 1, and 1 to infinity. We can go ahead and test. We're going to test negative 2, I'm going to test 0, and 2. Again, remember, any number in that interval is going to work for us. So we're looking for the sign of f prime of x. F prime of x, if I plug in negative 2. Well, if we notice here, the 5 is always going to be positive. X squared plus 1 is always going to be positive as well. So it's these middle two that are going to determine if it's positive or negative. If I plug in negative 2, I get a negative, and I get a negative. A negative times a negative gives me a positive. If I plug in 0, I get a negative and a positive. Negative times a positive gives me a negative. If I plug in 2, I get a positive times a positive or a positive. So I'm increasing, decreasing, and then increasing. So I have a relative. If I increase to decrease, I know I'm going up and then coming down, so I'm going to have a relative max at, again, in this interval change between negative infinity, negative 1 to 1 is going to occur when x equals negative 1. And I'm going to have a relative minimum, because I go from decreasing to increasing, when x equals 1, so I can go ahead and find that point as well. So let's go ahead and go up to our original function. If I plug in negative 1, I get negative 1 to the fifth. So negative 1 to the fifth minus 5 times negative 1. So I get negative 1 to the fifth is negative 1 plus 5, which gives me 4. And if I plug in 1, f of 1, I get 1 to the fifth minus 5 times 1. So 1 to the fifth gives me 1, minus 5 gives me negative 4. So I have a relative max and I have a relative min. And what we can do, since we've got this information, these points, we can go ahead and start graphing. Nothing wrong with that. So we have negative 1, 4, 1, 2, 3, 4. We're going to plot that point. And then 1, negative 4. We can go ahead and plot that point as well. As we've got our, our first derivative there, we can go ahead and do our second derivative. And remember, second derivative is going to tell us our points of inflection and our concavity. So our second derivative here, we can go ahead and find which one we're going to use. I would go ahead and come back way up here to 5x to the fourth minus 5. Find our derivative there, we get 20x to the third. Set that equal to 0. So we get x equal to 0. So for my concavity intervals, I just have negative infinity to 0 and 0 to infinity. Go ahead and find some test values. I'm going to test negative 1 and 1. Now I'm looking at the second derivative sign. The sign of the second derivative. If I plug in negative 1, I get negative, and 1, I get a positive. So I'm concave down, and I have concave up. Since I have a change in concavity, I have a possible point of inflection in there. If I plug in 0 into the original, I see, do I get a point out? So 0 to the 5th is 0, minus 5 times 0 gives me 0. So I have a point of inflection at 0, 0. What else can I find? Well, I could go ahead and find my, my x-intercepts. How do I find x-intercepts? I take my original function and set it equal to 0. And I go ahead and solve for x. So I can take an x out of that. I get x to the 4th minus 5 equals 0. So x equals 0, which we know. And we also know that x to the 4th equals 5, or x equals the 4th root of 5. When we think about the 4th root of 5, well, what do we know about our 4th roots? We know that 1 to the 4th is 1, and 2 to the 4th is 16. And 5 is really close, or much closer to 1 than it is to 16. So we know it's going to be right after 1, isn't it? And if I think about the 4th root, if I can take the 4th root, I have the positive and a negative value of that. So I'm going to be just past negative 1 and just past 1 as I graph them. So I'm going to be maybe in here and in here. Again, not miserably, terribly difficult to find. You should be able to find those somewhat with ease. So we now have enough information to be able to graph or sketch this graph. We know the zeros. We also know these points that go through it. More importantly, we know that we're increasing from negative infinity to negative 1. So from negative infinity all the way to negative 1, I'm coming up into it. From here, from negative 1 to 1, I'm decreasing. And from 1 to infinity, I'm increasing. So it's going to look on the cubic side, isn't it? We also know our concavity, we're concave down from negative infinity to 0. So from negative infinity to 0, we're going to be in this downward U shape. And from 0 to infinity, I'm going to be in the upward U shape. And I change at this point 0, 0. So let's see if we can't sketch this in a little bit. So I know I'm in a U shape here. So I'm going to start here, and I know I got to go through this point. So that's going to be that part of the graph. So I'm increasing and then decreasing, and I'm concave down. And then I change my concavity, so I'm going to change my curvature. I'm going to go up. And that's going to be a nice sketch of this graph. I have one more to work on today. Another polynomial. We have x to the third plus 3x squared plus 1. Again, we can go ahead and find the first derivative, which gives me 3x squared plus 6x. Set that equal to 0. I'm going to factor out of 3x. I get x plus 2 equal to 0. So x equals 0 and negative 2. Go ahead and do my intervals. So negative infinity to negative 2 to 0, and 0 to infinity. Again, making my intervals about those x values. My test, I'm going to test negative 3 and negative 1 and 1. And I'm looking at the sign of the first derivative. So if I plug in negative 3, that's going to be giving me a negative times a negative, which is a positive. Negative 1 gives me a negative and a positive, which gives me negative. And then 1 gives me a positive and a positive, which gives me a positive. So I'm increasing and then decreasing and then increasing again. So I have a relative max at the point negative 2 something, and a possible relative min at 0 something. So let's go ahead and plug those in and see what we get. So f of negative 2 gives me negative 8 plus 12 plus 1. So that gives me 5. So I get a point negative 2, 5. Come over here and go ahead and plug my point in, negative 2, 5. If I plug in 0, I get 0 plus 1, or 0, 1. And that gives me my 2 points that I have relative max and relative min. So I know this is the highest point in this region. This is my lowest point in this region. My second derivative, I'm going to go ahead and find, which is 6x plus 6. Set that equal to 0, so x equals a negative 1. So my intervals for my concavity, I get negative 1, negative infinity to negative 1, and negative 1 to infinity. Testing, we get negative 2, and we get 0. So my sign of my second derivative, if I plug in negative 2, I get a negative, and 0, I get a positive. So I'm concave down, and then concave up. So I have a possible point of inflection at negative 1. Plug that in to our original function. So f of negative 1 gives me, well, we get what? Negative 1 plus 3 plus 1, which gives me 3. So I have the point negative 1, 3 as my point of inflection. As far as my zeros go, if I take x to the third plus 3x squared plus 1 and set it equal to 0, that's going to be very difficult to find that point of that x-intercept. So I'm not going to worry about that x-intercept. Not easily found. We could put it in a calculator, but if we could put it in a calculator, we'd be able to graph it, and we wouldn't have to worry about it, would we? So I'm not going to worry about my my x-intercept. My y-intercept, I already found my y-intercept was 0, 1, wasn't it? Because we crossed the y-axis at 1. So do we have enough information to graph this? And I think we do. A rough sketch anyway. Again, we're going to be increasing to our first critical point, and then decreasing, and then increasing again. We have that point of inflection where we change our concavity. We're going to be concave down and then concave up. So again, I like to start at my point of inflection when I graph them. Makes a little more sense to me. So it looks like we're going to go through at that point there. And then we're going to change the concavity again from the point of inflection. We're going to curve it up. And there we go. And that's a nice sketch of that polynomial. So that gives you an idea of curve sketching with polynomials, being able to find all that information, critical points, increasing, decreasing intervals, concavity, and putting it all together to be able to sketch a graph. Good luck and enjoy!